Alright, hey everyone, sorry if it's a little bit loud in the background. I am at a hotel in Anaheim, in the lobby. So, we'll just have to deal with it. But, here we go. So we've got, this is for the practice assessment. So, this first problem says, Mrs. King invested some money in the stock market. She tracks her gains and losses using a computer program. Mrs. King receives a daily email that updates her on all of her transactions from the previous day. This morning, her email read as follows. Good morning, Mrs. King. Yesterday's investment activity included a loss of $400, a gain of $720, and another gain of $300. Log in now to see your current balance. So problem 1 wants us to write an integer to represent all of these three things. So what you're thinking is this is the helpful reminder is when you look at a bank statement, and many of you probably haven't seen a bank statement, but if you go to the bank, it wouldn't say loss of 400, gain of, that's too complicated. They just use the numbers to show those things. So since this is a loss of 400, it's negative 400, and a gain of these, a gain would be you're getting money, so those are going to be positive. Moving on to number 2. It says, Mrs. King noticed that an error had been made on her account. The loss of 400 should have been a gain of 400. Locate and label both points that represent a loss of 400 and a gain of 400 on the number line below. Describe the relationship of these two numbers when 0 represents no change. So, still not super difficult. We just need to label a gain of 400. Remember, a gain is positive, just like these gains up here. And so that would be positive 400, and then a loss of 400 would be negative 400 right here. And so also notice that I actually labeled all of the things in between. I can't just put a dot and say that this is 400 and put a dot and say that that's negative 400. We need to know what all these little spaces mean. So I went by 50s, 50, 100, 150, 200, and so on. And then same way in the other direction. And I'm noticing that this is positive 400 and negative 400. Those are opposites. They are the same distance from 0. They have the same absolute value, but they are, one's on the right-hand side and one's on the left-hand side. So they're opposites. Okay, number 3. Mrs. King wanted to correct the error, so she entered negative $400 into the program. He made a note that read, the opposite, or it should be she made a note that read, the opposite of 400 is 400. Is her reasoning correct? And so, yes, that is correct, because there's two negatives. And remember that, say, like, 400 would be 400, right? And so negative 400, remember we can also think of the negatives as saying the opposite. So negative 400 would be the opposite of 400, and that makes sense, right? And then so when you have negative 400, you're thinking the opposite of 400. And we can actually think of that, when you have, here's my number line, 0. If I have 400 out here, well, what is the opposite of it? The opposite would be negative 400, right? And then the opposite of that would be going back to 400. So the opposite of the opposite is itself. So that all makes sense. Let me erase this a little bit so we can see the bottom. And moving on to the next one. For number 4 and 5, it says, at 6 a.m., New York had a temperature of negative 6 degrees Fahrenheit. At noon, the temperature was 14 degrees Fahrenheit. And at midnight, it was 21 degrees Fahrenheit. Number 4 says, write a statement comparing negative 6 and negative 21. So I'm going to say that negative 6 is greater than negative 21 as a temperature and on a number line. So either way you look at it, negative 6 is greater. And I made a vertical number line right here that to see that I have 0, and then I would go down a couple to negative 6, then go down even more until eventually I got to negative 21 degrees. So that's just kind of, I made a vertical one because it's more like a thermometer. And I can see that 6 is closer to 0. It's also going up, so it's greater. And then 5 says, Write an inequality statement that shows the relationship between the three recorded temperatures. Which temperature is the warmest? So the first thing that I did was I said, actually I left part of the answer out on this one. The first thing I did was I drew a number line. You don't have to draw a number line, but I did one just so I could visualize it, so I could make sure I'm not making mistakes. And then I just took the first two, 21, I could start off with this inequality. Negative 21 is less than negative 6 because it's more to the left on the number line, right? This is less than this. And then negative 6 is less than, you can kind of look at these two. Negative 6 is less than 14 because negative 6 is also to the left of 14 on a number line. Okay, and then it said which temperature is the warmest. So the warmest would be, 14 degrees is the warmest. Okay, because that's the greatest temperature. Okay, moving on to number 6 says explain how to use absolute value to find the number of degrees below zero the temperature was at midnight. You can see right here that I said the absolute value of negative 21 is 21. So I can say the absolute value of negative 21 is 21. So the temperature is 21 degrees Fahrenheit below zero. All we're trying to explain here is that the absolute value tells us that negative 21 is 21 degrees. So if it's a negative 21, it's telling us it's 21 degrees below zero, because negative 21 is still 21 as a distance when you measure it from zero. Number 7, in Seattle, Washington, the temperature at 6 a.m. was negative 4 degrees Fahrenheit. At midnight, the meteorologist recorded the temperature was negative 12 degrees Fahrenheit. He concluded for temperatures below zero, as the temperature increases, the absolute value of the temperature decreases. Is his conclusion valid? So here I have this right here, and this is kind of, here we have another number line, and if the temperature was increasing, it would be going to the right. So we'd be going negative 12, negative 11, negative 10, eventually we get to negative 4, then we get to 0, and then we start going positive. And what you should notice is, as long as you're below 0, right, let's say we start at negative 12. Well, if I increase my temperature 1 degree, I'm at negative 11. Then I increase it another degree, I'm at negative 10. As I increase that temperature, my absolute value went from negative 12, the absolute value would be 12, and then it would go to 11, and then it would go to 10, and then eventually here, it would end up, my absolute value would be 4. So as my temperature increased, as I got closer to 0 in temperature with the negatives, the absolute value got a little bit smaller. So this is true. Next one. Choose an integer between 0 and 5 on a number line and label the point P. So this one is pretty straightforward. Between 0 and 5, and I picked the 3 and I labeled that P. And then it wants me to, 8 says locate the opposite of P. So the opposite of 3 would be negative 3. So I found that here and I labeled that A. And then number 9 says label point B a number less than P. So I'm looking at P, and anything down here could be point B. I just picked 0 because it was a couple down. Then label point C a number greater than P. So any of these would be greater than P. So I picked 7. And then D said a number halfway between P and the integer to the right. So halfway between P and the integer on the right of it, which is here, because I wouldn't have this one in. So halfway between these two. So I put it right there, and that's D. Okay. You could have also picked a different number. You could have picked something like 2 to start, and then it would be negative 2 for A, and then a number less than could be like down here, and a number greater than could be up here, and then halfway between would be like here. It all just depends on what number you pick the first time. So it's kind of on a question by question thing. You can have a couple different answers for this one. Okay. On to 12. 12 is very much like the very first problem. There's just more. Oops. There's just more numbers to write with. So we have all of these descriptions up here, these sentences, and we have to write each of those integers that they are represented by. So Mount Whitney is the highest point in California, 14,500 feet above sea level, positive. And Death Valley is 282 feet below sea level, so negative. Lake Tahoe above sea level, so positive. Sacramento 30 feet above, so positive. The San Francisco coast, which is at sea level, so that would be 0, because it's sea level. And the low city is Bombay Beach, which is 223 below sea level, so that's another negative number. And then we have explain what negative and positive numbers tell Corey about the elevation. Corey was talked about up here in the problem. Corey's learning about the elevation in math class. And the positive numbers, when I'm looking here, the positive numbers are telling me that the land is above sea level, and the negative numbers are telling me that land is actually below sea level. So if imagine you have sea right here, and then this is the land, and then we have some valleys and stuff like that. So anything in here, all of this land would be negative, right? Because it's below, here's sea level. So anything down here is below sea level, that'd be negative. And anything up here or up here would be positive, because that's above the sea levels right here. Okay, and on to 14. This says order the elevations from least to greatest and then state their absolute values. So these are the same exact elevations from the last problem. You're just putting them from least to greatest. So imagine those numbers on a number line from left to right, and we're just writing them here. So we're going to start with the lowest one. That would be negative 282, and then negative 223, because that's closer to 0, right? Then 0, then 30, then 6,000. 225, 14,505. And then we're just writing the absolute values here of all of these numbers. So really all the positive ones should be the exact same. And these negative ones, negative 282 is 282 units away from 0. Negative 223 is still 223 away from 0. So this is just, really all these are just those positive measurements of distance from 0. 15 says, circle the row above the table that represents sea level. So that would be 0. This is the row that represents sea level, because it's 0 would be right at the sea level, not above or below it. And it says, describe how the order of the elevations above and below the sea level compare to the level of their absolute values. So what does that mean? That means that what does the absolute value tell us about all of these elevations? Well, these negatives and the elevations tell us it's below sea level, and this tells us it's above sea level. But when you just look at the absolute values, it's telling you how far away that land is from the sea. So if I look at the elevation, I can tell that this is 282 feet below sea level. But if I'm just thinking about the number 282, it's telling me, well, how far away is it at? It's 282 feet. So we're just measuring how far away it is when we look at the absolute value. Okay, the last one. This says, for centuries, a mysterious sea serpent has been rumored to live at the bottom of Seneca Lake, the longest of the Finger Lakes. A team of historians use a computer program to plot the last 5 positions of the sightings. So, 16. Locate and label the locations of the last 4 sightings. And that was A, 9, 2, so up to 9, 1, 2, A. And B, 4, negative 2.5, so I'm going to count over to 4, and then I'm going to go down 1, 2, and a little bit more, right? So you notice I'm between 2 and 3, because 2.5, negative 2.5. Let's see, 8, 0, 8, going over 8, and then up or down 0. And then D would be negative 3, negative 2 for D. And 17 says, over time, most sightings occurred in quadrant 2. Write the coordinate of a point that lies in quadrant 2. Remember, this is quadrant 2. Remember, we start with this quadrant 1, because that's kind of like how, imagine the old, when you very first started graphing, they kind of looked like that. You'd have bar charts, right? So we always start with number 1 over here, this upper right one. So this one's always number 1, this one's number 2, and then 3, 4, because old French people made it, so it's counterclockwise instead of clockwise. So this is, that's not really why, that's how I remember it. This is quadrant 2, so any point in here can be an answer to that. Although it does say we are locating a sea serpent, so it would be cool if it was in the water instead of on the land. You probably wouldn't see a sea serpent roaming around on the land. So I picked right here, -6, 1, and I put a 17 by it so I know it's the answer for 17. But you don't have to do that. I just picked -6, 1. And then 18 says, what is the distance between point C and the point -8, 0? So here is point C from problem number 16. And then here's -8, 0. And how far away is it? Well, what you might notice is this is 8, 0, and this is -8, 0. These are reflections over the y-axis, right? Here's the y-axis, and we're crossing over that when we go. We go cross over the y over here. So what we can think of is, if we were trying to measure how far away it is, we know that this is 8, right? This is 8 away. Well, so if this also should be 8 away too. So it's a total of 16 away, which I wrote here, 16 units. And 19, what are the coordinates of point E on the coordinate plane? So E is right here, and we just have to write the coordinates, -6, 4. And then 20 says point F is related to point E. So let me scroll up a little. Point F is related to point E. Here is point E right here, and we wouldn't have point F yet. It wouldn't be there. But here's point E. Its x-coordinate is the same as point E's, but its y-coordinate is the opposite. Locate and label the F point. What are the coordinates? So what I could do is I can actually look at point E. Let me get the eraser here real quick so you can see. It's not letting me erase. So point E is at -1, 2, 3, 4, 5, 6. So this is -6, 1, 2, 3, 4. So point F should also be at -6 down here, -6. But its y-coordinate, right, because the -6 and the -6, the x, it says is the same, but the y has to be the opposite. So this is +4, so this is going to be the opposite of +4 is -4. So you could actually use the description just to figure out what the coordinate points are, or you could kind of just think, oh, that's a reflection. So you could also just go, I'll just cross it over as a reflection. But you could also use the coordinates to describe it. And then we know that point F is -6, 4, so -6, 4. And how far away are the points E and F? So I can look back up here, and I know that E is 4 away from here, 1, 2, 3, 4, so this is 1, 2, 3, 4, so it's a total of 8 units. Alright, I hope that helps. I know it was pretty long, but hopefully that is helpful to everyone, and good luck tomorrow. If you have any questions, just wait till Monday and I'll help you out. Have fun.